more concept, and then hands-on, and then we'll call it a day. Any questions so far? So far, so good? Okay, so let's begin. We will start with the Zookeeper. Again, Zookeeper will be often asked in interview why people use Zookeeper. So Zookeeper, if you think about Zookeeper, is one of the orchestrator. So it's a middleman. So here you have master node. Everything is a master node. So master node has no idea how many data nodes you have. And master node is a machine. Sometimes we call name node, sometimes we call master node. Here we call data node, and sometimes we call task taker, like that. But what happened? The Zookeeper normally comes with a three servers. So normally we do 3 or 5. So they may ask an interview question, why do you do 3 or 5? The reason we do that, so if one goes down, you still have 2 Zookeeper working. Out of 3, they are clustered. Zookeeper always clusters, so you avoid single point of failure. Now, any data node, they register here. So anyone who can start, they register to Zookeeper that I am available. Now, Zookeeper, if this guy goes down, Zookeeper will mark that it is not available. So Zookeeper will keep track. It's kind of traffic controller. And master node always questions Zookeeper, how many data nodes I have. So this is Zookeeper become a middleman. And using middleman, you can decouple master node and data node. Because if you remove Zookeeper, then master node needs to know all data node, and data node needs to know master node. So that's called tight coupling. Zookeeper gives you flexibility. That let's example, you want to add any additional thing, you can keep adding anytime without disturbing master node. Because master node does not know, master node really depend on Zookeeper. Zookeeper will control who's coming, what, and all. And this gives you flexibility. So whenever somebody says scalable architecture, they use Zookeeper in the middleman. Zookeeper gives you that flexibility. It's a middleman. That middleman gives you that flexibility to do all those magic work. That's all Zookeeper has. Zookeeper is a free software. Overall, it creates as a cluster. Now, why we created 3? Why can't we use 1? So they always prefer that you use 3 or 5, because Zookeeper use 1 as a leader, and then others are kind of slave. So if you want to add something, the write part happen on leader side. 1 will be leader, write happens, and then replication happens. Read happen anywhere. So master node can read at any time, anywhere. Read can be done at any level, but write happens to master node, they call leader. But if leader goes down, Zookeeper will automatically make other guys leader. And this way you get a redundancy. And because you're having 3, so if 1 goes down, listen carefully, if one goes down, still you have 50 like total you have 3. So if 1 goes down, still you have 2 nodes can sustain the load. And that is the reason whenever you use Hadoop, you minimum use 3. But if you have an opportunity to use 5, it's a good thing. Going down, to be honest with you, the likelihood is very less. Why? Because Zookeeper doesn't do much work. It's just a registry where data node can register, master node read. So it's not doing any processing. So Zookeeper going down is not going to happen more often. I have not seen in my 10 plus years history with Hadoop, Zookeeper never went down. And again, you're using cluster. So even if it goes down, you will not notice. So if somebody asks, what is Zookeeper? Traffic controller. What is Zookeeper? Service register. What is Zookeeper? Decoupling master node and data node. What is Zookeeper? Zookeeper avoid the decoupling. So master node can be restarted at any time. Data node can be added and removed at any time. And that flexibility Zookeeper gives. It is popular. It has been proven in the market for many years. And Zookeeper started with version 1 and remained there. There was no additional version because there was 0 bug in Zookeeper. Zookeeper works in Windows. Zookeeper also works in Linux also. So that's why Zookeeper is a choice of registry. Before Zookeeper, people use LDAP registry. Zookeeper make simple, easy. So people now use Zookeeper. Spark also use Zookeeper. and many more software use Zookeeper. It is very tiny software. It doesn't take even more than 1,000 lines of code. And that's what Zookeeper is about. Any questions so far? The day Scoop introduced actually in 2017 or no, my mistake, 11 or 12, I started using Scoop. So it was wonderful. And I still use Scoop. Scoop only had 2 commands. The book, if you want to get a book of Scoop, 7-page book, the only 2 commands. So what is the purpose of Scoop? Make sure you know about it because in interview they will ask. So database and Hadoop. Database RDBMS and Hadoop. Now, if you have large volume of data, stored here, so if you want to bring that data to Hadoop, normally you copy paste data, you export, and you import. But if data is huge, you cannot do that import export, and it requires manual effort. So Scoop comes in handy. Scoop use HDFS, and it also use MapReduce. Listen carefully. So what happened? Let's example your data large. Scoop has the ability to slice the data and run parallel. So you get this data to HDFS, you get this data. So you can run MapReduce. So you are now bringing data from database to Hadoop with a parallel thread. Parallel threads means multiple threads gonna get data. So you can speed up the data import part from RDBMS to HDFS a lot faster. And it has the ability, if something breaks, it starts from where it broke. It has the ability to also be smart. Like example, if your primary key, then it knows that I got data up to here, so I will start from here. You can also say where clause. You can write a where clause as a query that I only need this data. So Scoop is very friendly, which only one command, import, to get data from any database in the world. It's not just a IBM DB2, it's not Oracle, it's not MySQL. Any database, you can bring data from table or multiple tables to HDFS, and very fast. And you don't have to write a single line of code. The only command, one command you need to write. The command is very simple, import. And then from where you are importing, then you write database name, username and password, and table or query. Either write table or write a query. And then you can say where you want to store in HDFS. And then you bring the data to HDFS. This happens instantly. And because it uses MapReduce, it's a parallel processing, and it's very fast. That's one use case where Scoop is used. But there is another use case is your data in HDFS or HBase or Hive, and you want to bring that data back to database. So if you want to bring the data to database, then there is a same Scoop has another command called export, where your source is here and your target is here. And this is also working very fast. The commands are pretty simple. So let me show you the commands. You will understand. This is what I was talking about. When you say Scoop import, right? When you say Scoop import, all your database data parallelly coming to Hadoop. So this, because of parallelization, Scoop bring data much faster. And this command you can create as a job. You can schedule a job like at a particular time, data will bring to Hadoop. And this is what you can schedule. You can run that command, import command, at 4 o'clock, 5 o'clock. So wherever your data warehouse, or wherever your large volume of database, people use Scoop to do this kind of work. Trust me, anybody can do this thing much faster because the command is very simple. And same thing for export. Command, extremely simple. So let me show you the command. This is the command, that's it. So you're saying Scoop, import, connect. This is the database. You can connect to the Oracle or you can connect to the MySQL. You specify the username, password, and you can specify which table you want to import. You can write table or you can say query, and you can write a query, and then based on the query, it will import. If you say M1, means MapReduce 1, but if you say M10, then 10 parallel thread will work. That's it. Import command, get data from database to Hadoop. Same thing, if you go to export command, it does reverse. Export command, get data from HDFS and bring to the database. And this is another command. So just 2 commands will make life easy for you. So many times in interview, people ask, if I have database and I have large volume of data and I want to bring to HDFS, how would you do? Majority people say export import, but actual answer is scope import command to bring data from database to Hadoop, and export command from Hadoop to database. And that this diagram will give you much more clarity. So whenever we talk about HBase, we talk about one master, and it creates a partition. So it creates a region server and region server. So think about that. You have master. So this is master 1, and you have master 2. And there is a top master that's orchestrate which master to take. So think about, you have two countries, US and Canada, and there's one who load balance. So this is the country US and this is the Canada, and here load balance. So you can say if requests come to particular way, you send to US. If requests come to certain way, you send it to Canada. And inside that, you're also creating a region, which is nothing but state. So like in the United States, you have 50 states. So you can have region server for USA, and inside that you can have 50. The dotted line means multiple. And same thing. So what is that mean? It's efficient in reading. So example, if somebody say, I want to go to Australia, so there is a region server for Australia. And in Australia, there are subsections which we call H region. H means high HBase. Region is nothing but partition. So if you're looking for a particular file, you can easily search. You can think about that. Country come first, then country through state come first, and then state to particular data. So you can see the navigation. Master will send you to country will send you to particular state, and then state to, you can get to particular partition. And ultimately, data is stored in data node. But this layer, which is called partition layer, which we studied in a Hive, if you remember that, this allow efficient search. You might see Google, when you're searching in Google, you get result much faster. Google use this concept. So like example, if government is India or USA or Canada, and if you're looking for government news, any request comes, it goes to the region server and say, hey, I'm looking for Indian detail. Automatically it take you to the region server. And from, I'm looking for this segment, government segment. And again, it goes to small h region. So it kind of does the partition. So because of that, it is not searching entire world and getting you data. It is searching particular segment and get you data. And all those things which you are doing here happens in memory. In memory. Because it's happening in memory, it is extremely fast. That's why Google bring their result in less than 2 seconds, because it's in memory. Google use this concept for read only. So sometimes people say, what is the purpose of HBase? HBase purpose is to cache. Caching means keep in memory. And it gives you read advantage. Read advantage means whenever you read something, you get a faster response. Writing part only once. Reading part. HBase is not anything else. It is a layer on top of HDFS. So if you remove HDFS, HBase won't work. It is a layer, just like Hive has a table structure. Here you have partition. Snowflake almost use similar concept. Snowflake, whenever somebody says Snowflake, it's a layer on top of HDFS or S3 bucket. So storage part, on top of that, Snowflake is this. So whenever somebody says Snowflake, it's on top of that. We call management layer. So management layer make it simple, comparatively accessible. All those things it does it. The reason it does, so you get result faster. HBase is known for faster retrieval. So if you want like very fast retrieval, HBase is the way to go. There's nothing special in HBase because if you see this example, it's same concept. So how does, when you come here, like you come here, how it works. So here we talk about USA, and it will come here. And then we talk about stateless New York, and inside the New York they use column family. So let's understand column family. So what is column family? So column family means normally we say rows like this. In the database world, we have column. Please understand column, and we have row in database world. In database world, you have column and row. It means each row will have identical columns. So 3 columns means each row will have 3 columns. This is the database world where schema is fixed. Schema is fixed. But in HBase, very different. First level, you create a column family. Column family. So total you have 3 column family. So when you say row has 3 column family, but column family is also known as a super family because super column. Super means is a bigger column. Then you divide that column family into sub, and that gives you flexibility. So management perspective, only you remember this, but data perspective, you create a sub column. So you can see this column family is subdivided into 3. This column family is subdivided into 1. This column family is subdivided into 2. It means you don't have to follow schema correctly. Example, for this record, you may have a 3 subfamily because column family 1 inside your 2, but this record, you may have 0 or you may have 1. So row to row, your column structures will change because you are not focusing on schema. You are focusing on a family. So example, if I say this is the name, column family is name. So here I can say column family title, first name, last name, middle name. I can create. Now some people will have only title and first name. Some people will have first name and last name. Some people have first name, last name, middle. Means row to row, you have flexibility. That flexibility you get because it is focusing on column subdivision. While in an old-fashioned traditional RDBMS, the row are divided into column. Row are divided into column. In the newer world, we call NoSQL. In NoSQL, columns are divided into further column. That's why this is called column-specific database. So column-specific database gives you significant benefit. Why? Because if you're looking for first name and last name, you look column and get the data. And because you're getting column data, that entire column is stored in one region. So in one shot, you get the data. And that's why it's so fast. In a RDBMS, you have to get record by record data. And record might be stored in different location. And that's why it's slow, because you are rotating hard drive in order to get the data. But here, instead of rotating hard drive, you are only bringing columns, and columns are stored together. And because columns are stored together, you can read much faster. And that anytime when somebody try to get data, whole Snowflake is a column-based database. Column-based database is designed for read fast because this entire column is stored in one location. So you can get it faster because you're not reading one line at a time and you're not spinning the motor. You're storing all at once. So when you read it, you read the entire segment. And that is the reason HBase, MongoDB, Cassandra, these are NoSQL are faster. They're column-based database. They are not row-based. So whenever somebody says schema-less, mostly schema-less are column-based. So example, if I need first name, last name, I just read that 2 columns. Table might have hundreds of columns. That may be table might have hundreds of columns. You don't have to look around because you look for first name, last name, they are stored in one location. You can get it instantly and give the result. So that's why Google is so fast, because Google know which column to look for. So Google created a nice column family concept. So like example, if you're looking for, let's say, website, they go to column website. If you're looking for some segment, they define this structure to get the data faster. Again, it requires significant experience to create this structure, depend on your use case. And your use case you need to know. So sometimes people ask, how you design? In RDBMS, you design RDBMS first, and then you design the application. In no schema or NoSQL, you first understand use case. You first understand use case. What is your use case? And then you create a structure. Why? Because then you try to get data faster. That is very popular in NoSQL part. And HBase is one of the best example because it's significant faster. And you see Google use their own HBase for faster retrieval. And these are the two topics. Anytime somebody asks how the storage work, start with hmaster, then regional, then region, and then column family. Column family is known as a super, and then sub column. Row by row, column may vary, so you don't have to have consistency because column family will be there, but sub column may be plus minus row by row. Column family is there, but sub column may vary row by row. One person may have two columns, another person may have one or three. And that is the beautiful part about schema-less. You get a flexibility. Row by row, you can change it. Questions? So you might notice. Social media, LinkedIn, or product, they use this type of graph. So graph navigation is so fast if you use graph. You can do a lot of surveys, like example, if you do comment create a graph, like example, city, and city might have some kind of thing. And then if transformer is not working for here, they can figure it out how many people will be impacted. So using graph, you can traverse much faster. So I have one example, and one example I gave you as a homework, you can practice. So let's understand. There are some terminology you need to understand. So the first terminology is if I draw this type of thing, then I want to make sure you understand this one, which you see here is a vertex. Sometimes we call node, sometimes we call vertex. So example, if I say O'Hare, ORE, from O'Hare, I'm going to JFK. So JFK is also node or vertex. So, or maybe I'm going to San Francisco, like that. So you can see here, if I say how many flights from here going here, it's A and B. You can add that. You can also find out how many what distance we are traveling. That's called age. So age is nothing but distance. This one is age. And triplet means from here to here you want to find. If you want to find here, this is called triplet. So there are three terminology you need to understand. Vertex. Vertex is nothing but node. Age, which is nothing but only the distance between these two. So this is the age. This part is age. And then triplet, which is the combination of two nodes and one age. If you understand that, then you have to develop. So entire network we have to develop. So example, you can have like example father and then son and daughter. So here you can say son. So this you decorate that son. You can, this is like qualifier, means what you are interested in. Son, if it is distance, then you can say how long this distance is per airport. Example, sometime your effort, like example 15 hours, you can do that also. A lot of things you can do, right? So example, I give you an example. Let's say when I was working for a big company where we have a windmills, we want to monitor windmills. So like this is a city, and in this city, let's say I have 5 windmills. So what is the distance for this windmill? So we can define that. So this will give us idea. So this part, like when I was working on a logistic area, like example, you're New York, you're going to warehouse, and there are many ways you can do warehouse. So you can find out which is the shortest path for delivery. That is what used by or UPS and others. When you're seeing the brown truck, right? Your house is a one node, warehouse is another node, and the distance is age. So you can find what are the path I can come to your house, right? When you're thinking about point A to point B, when you're traveling, right, point A to point B, you're starting where you're driving and destination where you want. And there are many ways you can go. So that the distance finding, which Google GPS or other you're using, they use this graph. So Graphx is very popular in industry, and that's why they want you to know. Concept start with only 3 points: vertex, age, and triplet. So far, so good. Any questions? Good. Now, if you see this, how it will work. And so this is the real example. As I said before, this is one of the most popular examples. So here I have city, and I want to know populations, another kind of thing. So this is city. Now, each city, you can decorate something. Like example, I can say, what is the population? Or what is the unemployment rate? You can do that. And the distance, maybe freeway distance, or if I'm traveling like by truck, then what is the cost, or what is the time it takes, right? There are so many what you call point of interest you can define. Can I define one? Can I define two? Can I define more? The choice is yours, right? Why? Because it's a point of interest. So here, these are all states, city, right? So you can see here, we have one, we have two, we have three. So if somebody asks question, just an example, from here, A, I want to go here. How many paths you have? So you can see this path A, the path B, path C, right? Path D. Now, from this path, what would be the shortest? Of course, you have to calculate the distance, right? If somebody asks, what is the cheapest? Then you have to consider cost, maybe toll way, right? Somebody says, what is the fastest? Right? Maybe you have to, or what is the safest? So each age has some mark, which you have to use that mark in order to calculate. Now, this one looks pretty small, but when you're driving, there are a lot of, I would say route segment you change. Everything happens in lightning fast. So Spark can do instantly. Spark has a library called Graphx. That library makes Spark instantly powerful. So how does it work? So let's see here step by step. So if you go here, first we're going to use library called SparkX, Graphx. And this exercise is written in Scala. So we are using Scala. Again, you don't need to know Scala in and out. This is just an exercise, but concept you will understand. Now, first we are decorating vertex. So you can say Philadelphia, that's one city. And we say this is 1, 2, 3, 4, 5, 6. Total 6 cities we have. Each city has a name, and each city has a population. Now, can I add other thing? Yeah, as many things you want to add, you can add. Like example, if let's say unemployment rate, or some kind of like example, Republican or Democrat, whatever you want to decorate, just do comma separated. You can keep adding that. Okay, this is the node. Node is identified by this number, and node has attribute. Just like database table has attribute, you can add as many attribute as you want. It's your point of interest. Good. So far so good. First is the vertex. Now, please understand, this vertex you have, between this vertex, you are having edge. Now, if you have one side edge, or you can have bidirectional edge. Now, many people are confused with that. If I have A node, and if I have B node, if I say going this side is costing me $50, coming back, how much will it cost? What do you guys think? From node A going to node B, if costing me $50, if I want to do reverse, how much will it cost? Are you guys there? Guessing?
The same.
No, it doesn't take the same cost. Why? Because roads, you are not coming exact same road. Sometimes you may have special detour to take, sometimes you have to do up, sometimes down, sometimes up. It is not the same. So depend on which path you're taking. If you're going to A to B, cost might be different. If you're coming from B to A, cost may be different. So you need to ask that, because sometimes you might be going and you will know that going A to B maybe take X time. Coming back will take a Y time. 99% it will not be same. Why? Because the roads are different, segments may be different, traffic pattern may be different, maybe I path is there, maybe speed may be different. So a lot of things are different. If it's small, maybe yes, same. But if you have city to city traveling, definitely there is a different cost. ETA will be different. So you need to think about that. Is it a one way or a bi-directional? And then you can define. So example here, population. But if I define age, I can define two age, A to B or B to A. Again, choice is yours. So now go to next level. Let's go array. If you see carefully, you will be understanding what I'm talking about. So right now, Philadelphia is number 1. That's a node. So I'm trying to do node 1, to 2. So here you can see 1 to 2. So here, so it's not like 1 to 2 is going. So this is 1. Philadelphia is 1. So the graph, you have seen the graph. So here, let's see here. So 1 to 6. So from 1 to 6. So Philadelphia to Scantron, 1 to 6. And 1 to 5. So Philadelphia to New York, you're going. So there are only 2 paths I can see here. So let's go here in diagram and see here. So Philadelphia is here. So Philadelphia to New York and Philadelphia to Scantron is different. Now, this is going, it means what? Flight is going this direction only. Makes sense? Can I define this? If you have this line, then possibility is there. If you don't have line, then that will not be used. It's very important because you can have city doesn't mean flights goes there, right? Maybe New York to is not happening, right? So what is available? That's what we are saying. So we have 6 city, each city. So here, if you see here, number 2, Baltimore to Harrisburg. So you can see here 2 to 3. So Baltimore is here. So Baltimore to Harrisburg is possible, right? But Baltimore to New York is not possible because you have to go through hoops, right? So we are defining how the network is designed. So we are saying if you have to understand this is possible and the distance is 1. If this is possible, this distance is. So you're defining the edge, how the flow is going to happen. So define this. Now you come here and you are saying the word, this one is RDD and you are doing parallel. So Spark can do parallel search and Edge also, it does parallel search. So you create this array and you're asking Spark to do RDD. And then this RDD, you create a graph. Again, you don't have to memorize it because you're creating a graph. So now graph is ready. Now you can traverse the graph. The goal of the graph is to find something, filter something like that. So this graph will be created in memory. Now you ask in the graph, show me the population which is more than 50,000. So graph is ready. Now because graph is ready, now you can use simple command like that, ID, city and population. If population is greater than 50,000, then loop it and show the population of city and the population. So it is going to use that graph because you are saying graph, but this is all available because you're using Graphx library. So you're saying graph vertex filter, show me all city and its population which is more than 50,000. And within a second, it will get you this data. Now, why it is getting there? Because your graph is in memory and you give a condition. So it's basically filtering the graph, it's searching the graph, and you get the city. Now, if you say triplet, if you see the question, one of that graph is exposed through the triplet. There is one triplet for each edge, right? About both vertex and edge. Let's take a look through graph triplet directly. So here we are finding distance here. So here, check it out. Example, we will find the distance between the connected cities. So here we are saying triplet, we are looping this, and it's a distance between the start with A and then B, and what is the distance? So you're traveling from A to B, so it gives you distance about each one. What is possible? So you're traversing each, Baltimore to here, so this is the distance you are traveling. Now if you go here, that once you have that, you can say distance between the 2 nodes is less than 150. So wherever less than 150, it's going to search it. So you can see here, these are all possible distance, but you're saying, no, I don't want to know all. I want to bring the distance which is less than 150 shown. So it will filter out and get you the result. So you can add a conditions. And now you're getting that thing. So when you are looking for, like, flight, right? You're looking for flight. And if you go to Expedia, in Expedia, you say, you know what, I want to travel in the morning and I want to land on this time. You are using Graphx internally. So all hotel booking sites, like air booking sites, they use graph. Why? Because you have distance and it's significant faster. You may say, but can I do in database? You can, but in database it will be very slow. But here you are developing graph and you know that your purpose is a graph. right? So if you're more interested in distance, you're more interested in time, more interested in cost between two nodes, graph will be much faster. So searching flights, you're actually using this Graphx. Again, you don't have to learn much. You just need to understand how this works. And mostly it's a book cut and paste type of thing, because mostly you're going to do filter, because that's what you are doing. Select statement is nothing but filter. So when you go to any website, you search something, that's your filter. There are few filters you can apply, right? You can apply filter as based on node. You can apply filter based on the what you call distance, or you can apply filter based on addition. So you're getting two nodes, right, coming this side. So you can say, what is the maximum I can get, right? Example, I have nodes. If I have 3 nodes, just an example, I have 3 nodes like that. So I'm going this side, I'm going this side, and this one is coming this side. So I want to know, like, what is total I can get, like, because you're getting input. So you can add also this side, you can also this side, and it is easy for you to do calculations. Like example, traffic is coming, flow is coming, income is coming, you can do that. This is also often used for water line. So water pipeline, you're getting water bill. The water bill is calculated this way. You're getting electric, you're getting common gas, this is calculated this way. So that's why it's extremely popular in industry. And unfortunately, no one teach in college, right? Though it is hardly 10-minute exercise. There is nothing, you don't have to do memorize anything, cut and paste. The only thing will change is this distance. So when you look for Pizza Hut and you enter zip code 6 something, you are using Graphx. So whenever you search by zip code, Graphx. Make sense? It's a lot more popular in industry because there are a lot of use cases you can do it. Another thing is aggregation, which I talk about, that hey, you want to sum something. Then you can sum that. So here you can sum, like you can say A and B. So if flow is coming, like if one node is receiving flow for 2 sides, you can also aggregate and say, what would be the maximum aggregation I can do? So that is also I can do now. Okay. So we want to do the exercise. So I have created an entire exercise for you. What we need to do is we need to create a node. We will do 4 exercises and then we'll call a day. And all 4 exercises are very popular. So this is a whole Spark enchilada. We'll do Graphx, then we'll do joins, right? We'll do joins, and then I'm going to do product recommendations. So you get an idea how it works. So these are all simple exercises, but this is often used in a real life. Spark itself is very simple because it's a Python based. Spark allows you Java, Scala, Python. Majority people use Python, but this specific exercise I have done in Scala. So why don't you go ahead and create a Spark cluster, and we'll do the exercise. Right? So let's create a Spark cluster, and I'm sure it will be fun. So let's do that. So right now we're going to log into AWS console, and then we can sign as a root. Right? Let's complete this thing. Method code. Let's see if I have that code. New code. Oh, 772. And I'm in. I hope you are able to log in as well. And we'll create a Spark cluster. Please remember, whenever you create a cluster, don't forget to stop, otherwise cluster will cost you really good money. So when you come in, the first thing you do is go search EMR, and we'll click on EMR, right? We have been doing for a while, so I'm hoping you are now accustomed with this. It's extremely simple. So once you are in EMR, click on create cluster. So when you click on create cluster, we are going to select Spark cluster. So this time we're going to give a name. Our name will be peg 21. So let's give 21. Make sure you give a name that you can remember it, and we'll select a Spark cluster. So by default Spark is selected, and you can see here If you want to enable Pig and all, you can if you want to, but we don't need it because we are only using Spark library, but you can always use. Now, it does Spark can use Hadoop, which we did last week. Spark can use Hive, which we also use. Are you guys able to hear me? Are you guys able to hear me? Yes, no? Okay.
Yes, we can hear.
Sorry, because I thought my internet disconnected. Okay.
Yes, it was
Yeah.
freeze for a minute, then it
Yeah.
started. Yeah.
Now, if I scroll down, make sure you select the key part. So I'm gonna let me termination part. I'll control that termination part because before we go to that, I want to make sure termination part. I'll put it 2 hours. This is a safer side because I don't want to be interrupted. So termination part, I'm using 2 hours. After 2 hours, it will auto terminate that. And that part is good. Now scroll down and let's create a key pair. Again, I always suggest you can create always new key pair. So we're going to create a key pair, then we'll refresh here and we'll get our key here. Right? So let's create a key here. So click on that. This is something we have done it, so we can close it. We have been done. We done like almost 4 or 5 times. So right now, let's say Feb 21, and we're gonna create it. Just create key pair. Click on the create key pair, and we can get you started. It will be automatically created, and it will download in your machine. So key is downloaded. Always secure this key. Don't lose this. Now go back to your previous tab, and then select your browse button. Okay. In browse button, you're gonna refresh it. So when you refresh, we are going to use Feb 21, which is this, and we'll say choose. At this moment, any question, concern, doubt? Any question, concern, doubt?
And I think I've asked it before. You know, if we can reuse key, why do you create one each time? Is it just for demonstration purposes, or?
No. Excellent question. If you are, let's say, three bank account, right? Your 3 bank account and your locker, right? Would you keep the locker passcode same or different? Why would you keep same and why would you keep different?
So I can remember them, but I know it's not advised. But okay, yeah, point taken.
That's the same
Okay.
answer. So if you keep a same key, and if somebody get that, then they will hijack all your cluster. If you create separate key, then you have a security benefit because they might be impacting one, but they may not impact others. That's the only reason. So I always create. Why? Because I'm demonstrating, I'm recording my session. Some of you are smart. Maybe you can create a key. But if I do every time new, think about my videos are in YouTube. Some people might be very smart. They can create a key. They can log into my cluster too. So that is the reason I'm keep creating a key because, and I destroy it also. So that key I never use again. So even though somebody recreate the key based on algorithm, they will not be able to log in because I'm creating always new key. That's the reason. But if I keep the same key, I give them 6 weeks to temper it and they might be able to. Some people are smart. They can recreate it. It's hard, but it is possible. Good question. Now, after you select this, you're gonna click on create service role, right? You may like this exercise, which I'm going to show you. It's tiny, but it's really important. And click on create instance. So we click here and we click here. So in case if you want to go back, just go quickly check it out. What we did, making sure you don't rush. You have selected the name. You selected Spark, right? Nothing, I didn't change anything. Now I have added termination clause that after 2 hours. So that gives me enough time to complete my plan. Then I select create a key, which we created from here. We refresh here, we got it here. Then I click on create service role. To service role, I created instance method. Now click on create cluster and wait for a few minutes and your cluster will be ready. At this moment, any questions? Okay, thank you, Maliki. So we have good. Please understand. Creating cluster.
Sorry, I'm late to share today.
No problem. No problem. So right now, cluster is in progress. In a real life, trust me, you also stop the cluster because you don't want to pay. This is expensive cluster. In real life, just to give you an idea, when I was working for Sears and Nokia/Microsoft, our cluster used to be 4,000 or 400 nodes. Even this cluster has only 2 machines. It cost me one hour, maybe around $2-3. So if you have 4,000, do math. Per hour, $8,000 per hour. It's a lot of money. And if you keep it for a whole day, it's going to be almost $100,000. Do you see the problem here? So this type of cluster, you need to be very, very cognitive. Just use it when you need it. Otherwise, it's going to cost you arms and legs. And that is another reason most people don't teach this type of class because it costs money, right? I humbly request you. Many of you are not doing homework. I completely know that. Many of you are not doing lab, not doing quiz. You are missing a lot of money on table. You will work hard, work smart in real life, but you will be surprised the person next to you is using this technology, making more money than you, more satisfaction. Why? Because this is very advanced. No one will do micromanagement. People will depend on you because no one knows about this thing. So again, I'm requesting, put yourself in a box and learn and practice this. These videos I'm not going to keep long term, so I'm converting it to YouTube so you can get those things. And this kind of class we normally don't offer every 2 months. We offer after 6 months because it requires database knowledge, AWS knowledge, Linux knowledge, cloud knowledge, all things. Then this is the capstone class. So don't miss out. Again, I'm saying next couple of weeks, give yourself real goal and finish these videos and all. Trust me, you will be lifetime remembering me. Otherwise, you will miss that and you will have regret when you go in interview or real life. I wish I could have done. Remember, that regret will remain with you. Still your opportunity to turn around. So make sure you do that because you will be surprised how easy and how powerful you have this thing. Okay. Right now, my node is ready to go. So let's click here and get in. So first we will log in. When we log in, we'll get our prompt, Linux prompt. We don't have to do anything here. Just click on connect. Just like we are doing so far. Click on connect and we should be able to log in. As we see here, we are able to log in. So please understand when you log in, Spark takes little time. So sometimes you might not see Spark running. So sometimes if I run like this, like example, Spark submit, if you run like that, sometimes it will say command not found. Don't panic. It means it is in progress of installing. Sometimes it takes time. See, I press enter, it is taking time, or sometimes it will say command not found. Don't panic. It is installing. The background job is running. You can see it's not running for me, taking time. This happens because it is installing. And now it works because there is a job running, which is installing software. It takes a few minutes, but after a few minutes, everything is done. So at this moment, my Spark is ready. Any question before we do this exercise? Good. So first, if you are with me, I'll put a link in the chat. You don't have to do anything. You just need to follow a few commands and you will be able to run this exercise. So this is a Scala lab. So here I will use my graph. That's a file name. So we'll say vi my graph. That's a file name, my graph. And then we'll copy paste entire code. Now, sometimes Spark use library called NumPy, Pandas. So we may need to install, which I'll show you how to install. But overall, it should not be a problem. So if you see the code, it's pretty simple. It has all comment. First, I'm creating vertex. Vertex means node. Each city is a node. Then I'm going to create edges, possible edges. I'm not going to create all edges because it means edges means from here you can travel here. That's what. But doesn't mean you can go back. Please understand. It's not a guarantee that you go back, because sometimes you don't have that distance, then you don't have a way. So you have to prepare the graph. Some graph may have a single line, one direction. Some graph may have two directions. So you have to define that edge issue. This is very important. Now you say, who will define it? You should know about it. Flight is going from Chicago to San Francisco, just an example. But San Francisco to Chicago is not coming. It might be going through in the middle airport and then it coming. So choice is yours. Questions?
Yeah, I haven't seen that script yet. I guess that showed you that Spark. Should I see that, or is there something that I need to?
It will take time.
Oh, okay.
I hope you are creating Spark cluster, not Hadoop cluster.
I did, yeah. Spark. Yeah. So the first one, the first option.
It will come. It takes a couple of minutes, as I say. Sometime it takes time, not all the time.
I connected when you did, so I saw yours popped up. Okay.
Yeah, it did take time. I have seen many, because just to give idea, but before I teach, I spend time. I spend time and I do the labs. My goal is to, I'm not sure how you study, but I study very seriously. I'll be honest. And if you are entering this field, you need to be learner. You can't say, I'll do tomorrow. Let me repeat. Then you will not be able to survive in this field, because in this field, do it now, like that. Because the essence is speed. That's the reason they are giving a lot of money. And speed, you're having clusters, right? So everything is like that way. The installation, when you're doing, the software is running, but it's not completing that. That's why you're getting error. So Spark submit. If this is not working for you, if you wait for a few seconds and try, it should work. If it doesn't work, nothing will happen. We can't do the lab. So it has to work. Good news, if you're able to connect, and if you have selected Spark cluster, after a few minutes, it should work, because it's a no-brainer. No-brainer in the sense of we are not doing anything. It is done by AWS, EMR. EMR is doing that. You are not installing, they are doing it. So I don't see any reason you will have error after a few minutes. So give a couple of minutes.
Okay. Yeah, mine just worked. I just didn't know if I wasn't waiting long enough. Okay.
Yeah. So anytime you do exercise, you may need to set up this type of node, and this two things you have to set up. This is your input. Now, some people read this through database, some people read through files, but you have to prepare it. And the rest of the thing is creating a graph. So these 3 lines create a graph. Once graph is ready, then you just query that. That's all. You query that and you filter, just like you're running database workflows. Here you're running query and you analyze. And these are your small code. This code is nothing but query. So here you are saying, show me all city where population is greater than this. That's one code. Second code is saying, find city 1, city 2 distance between them. And you're saying, show me the distance. So here you're not querying, you're just displaying the result, point A to point B. The next one you're saying, find system where distance is 150 or more. So there you are doing conditions. Now the next one you're saying, add the reverse directions. So we talk about reverse direction, and then show me the total sum. So these are all different labs. Now, how does it work? So I made everything together. So what we need to do is we need to copy this command. So I'm going to copy from here, import. I'm highlighting, and I'm going to copy this. Make sure you copy up to this. Control C, copy that. Control C. Then you go to your what we call EC2, and here we must say VI, and we can say my graph. We're going to say VI my graph, VI my graph, VI my graph. Press enter, and you can say I for insert, I for insert, and right click and paste. Entire code is written here. Right? Entire code is written. Please understand, this code is written in Scala. So sometimes you may not understand. Don't worry about it. You can write the similar thing in Python, but the library I use is like a Scala library. So I thought it give you another opportunity that you don't have to say, I don't know Scala. You know Scala. You just cut and paste. Majority code in Hadoop or Pig or Hive, if you ask me, majority means 80% code, you just cut and paste. Only 20% you massage. And anytime you don't understand, you ChatGPT, YouTube, Google, books, and all. Because you have to do that. There is a little bit like example here. Up to graph is very simple. But let's say this is the condition. Now, If you have other attributes, you may want to add another attribute. You have one example, and if they give you city has a population, now city has, let's say, CO2, right? CO2 problem. You can have attribute and you have condition for that. Let's say if they say population should be greater than this and CO2 like that, then you should have and condition, right? It's just like normal where clause, right? City equal to this and last name equal to this, like that. So you just need to be a little creative, but majority time that you're finding or summing, you're grouping, you're filtering like that. Right now, everything looks good. Now do escape, colon WQ. W means write, Q means quit, W means write, Q means quit. And when you do so, always double check get my graph, making sure it is working. Perfect. Now, the command which you are going to run, this one is this one. So here, you are not using Spark submit, but you are using cell, Spark shell. So what happened? My graph. So here, Spark shell, my graph. Let's say we do Spark submit. What happened? I want you to see first. So if I do Spark submit, and if I say my graph, see what happened. Spark submit. So what happens? So right now I say my graph, it didn't give you this error. This is a Java error. So I don't want to explain Java here in this class, and that's why I was hesitant initially. But then installing Java and all beyond this class, because you have to know Java, you need to set up the Java path and jar and all, which I cannot explain in this class. So I came up with a different approach, which is called Scala shell file. So there is a thing called Spark -shell, just like a grunt, interactive, and you redirect. Redirect means input, my graph. So how do you read this thing? You are saying, hey, Spark shell, read my program and interpret one line at a time and show me the result. That's all you're saying. Spark shell understands Scala. Spark submit only works if I have jars in a path, which I don't have it right now. It is possible to put that. If you guys are Java student, I would have done, but because you're not Java guy, it's hard for me to explain. So I kind of made it easy for you. Spark shell, my graph. Now when I press enter, you will see it will execute line by line and it will show you the result. So very soon it will create a graph, it will filter and it will start getting the result.
Excuse me, Tushar. I looked for, Google Class. Which week is that this file you are copying?
No, I'm not copying file. I put a link in the chat. You are not seeing the link in the chat? Everything is linked in the chat.
Okay, for this week or last week?
Of course, we are talking about this week only, right? I'm showing you here.
Yes.
Are you having a chat
Yes.
in front of you? See the last line? Are you having a chat?
Week 8, PowerPoint.
Please. Try to understand what I'm saying. Chat, Webex chat.
Webex chat.
Do you see the link?
Yes.
Everything is there and everything is in the Google Class also. Just want to make sure you understand. This is the week 8, Spark 2. Everything is there and we are in a Spark lab, Spark X lab.
Lab. Okay. All right.
Week 8 under PowerPoint. Week 8 under PowerPoint.
PowerPoint.
Yeah. And this is the what do you call my forum link where I have program. Right? So now it works.
Yeah, we have scoop, command, zookeeper, HBase, SparkX. Which one I should go?
Yeah.
Oh, SparkX. Okay, sorry. Yeah, thank you.
No problem. We are almost done. So we need to switch to other one, but just want to make sure others who attended. If you see carefully, it did run one by one command. So example, distance less than 150. Do you see that? It figured it out, all those things. So anytime you do analyze, you just need to copy this type of code. If this is your code, you copy here. You have to copy and paste the code. So example, you ask, hey, run this thing. So you can see this code, this particular code run here, right? Each code, see here, if you run this thing, this particular code run here, right? So example, if you want to change here, you can change and it will run accordingly and get the result. So Spark Shell is kind of interactive. You can cut and paste your code and it will work and you have that answer. You need to quit, right? The program will quit and you come out. So anytime you run the program, you just do Spark Shell, and my graph. My graph, entire program I copied, my graph. My graph, we have everything here, VI, my graph. And you can see that program starts from here. We started from everything is here. And this program we copied from our SparkX. This is the program we copied from.
Okay, thank you.
In case if you're not able to do right now, you can do later. This is simple, only one exercise I have for Graphx, where you copy from here to here, and I give a hint here how to run this program. This is the hint, right? And this program starts from here, end here. You create a VI, you save this program, and you run it. And when you run, it takes a little time, and then one by one you can see the result. So if you want to add another thing, you can copy this section, maybe change it, run again. If you want to change this section, maybe change the attribute, run again. If you want to change this, run. So basically you have 80% code in front of you. The only thing will change is here. Maybe you have an extra parameter. You may need to add here and maybe add a condition and you can do just like Java person does the programming. Scala is based on Java, so it's the same as Java syntax. Everything will work. Good. I would suggest you guys can do this exercise first, make comfortable, and then I have two exercises. This is just to give you idea how in industry people use. So this exercise is Berkeley University. So Berkeley University. Now they changed the link, so I can't help you. That's it. This one. They changed the link also. You see, this is people change it. The reason they change because it's not easy to teach such kind of things. But this exercise is mostly used for weather report. It is used for traffic. It is used for flight. It is used for water, gas, like that. So again, play around. Any question, concern, start. If somebody asks to add extra parameter, you just add a comma and add that parameter. So here you have two parameters. If you want to add 3, 4, you can do that. And then every time you have 2, then you have to use here 3, whatever you want to interest. Whatever you use here, these are your select statements. Select city, comma, population. Where population is this. Very simple. And this is your from the table. So table is this, the graph is your table. This is your selection column. And this is your where clause. Rest of the thing is just try catch. You don't have to worry about it. This is the looping. For each is nothing but for loop. Remember, you don't type, you copy paste. But you need to understand the concept. Whatever the attribute you're interested in, make here. Whatever the filter you want to apply here. And this is your graph. This graph you populate here. So if you made a mistake in a graph, result will be wrong. Graph edges, you make it here. And vertex you make here. Right? Some of you right now are hard coded, but you can create through programmatically. You can create the vertex programmatically. You can create vertex edges programmatically. So when you do LinkedIn does the command, right? You know him. Like example, I know, let's say, Priyank, and Priyank knows someone else. So LinkedIn will recommend that. Facebook will command that, right? The way, how does it recommend? It uses this diagram, right? Through diagram, I can easily recommend people. So Graphx is heavily used for social media and other sites. Good. Question, concern, start. Good. Now we're going to flip the topic and we'll do the other exercise. This time we are going to change the link, which is called Spark Lab, from our power. And that is the reason I'm saying go confidently. In this field, you don't need years of experience. You just need a common sense. So like example, let's say I want to do clustering. Clustering means grouping. Like example, somebody give me data file. right? And I want to cluster into 3 groups. So data files will come in a format, and this code which you need is Spark. So you just write in English, like example. Here you can say create a sample data file and show PySpark or Spark or show Spark or and write Spark program, Apache Spark. Let's write Apache Spark Python program to create cluster. Now this is kind of generic, so I can say create customer sample data file, customer sample data file, right? I can say with column. You can just make a column, like example, ID, email, order, state, and country, just like that, right? And then write a Apache Spark Python program to create a cluster based on state. Again, common sense, very simple common sense. Why am I doing this thing? Because I want to see how fast ChatGPT can. And then within a second, you have data and you have a program. Then you combine the program and generate it. Always start with hello world and then modify. So right now, within 2 minutes, you become expert. You don't need a data science degree. It will create a sample data file for you. Look at that. So create a data sample file. I don't think you will ask question why this is what it is, because I gave them, right? And if you scroll down, it will give me Python program. Look at that. Now reading the program. So first it's going to use some kind of library. So you can see here, it says clustering. That's the name. Now you say file has a header, which is this one. File has a header, right? Now if you scroll down, and now it says group by state and count and state, right? And I'm ready to go and I'm done, right? So I'll show you how I'm doing program in front of you without any prior practice, right? So this is the clustering. Now if somebody asks, what is clustering? If you do not know clustering is a group. In database, you do group by city, group by country. So like I want to do this exercise, right? Just an example. You don't want to see, just see here how I do it. So I copy this, right? Now, you need to have a little bit of understanding, but otherwise it's simple. So I came here, right? So yeah, I need to come out. Okay, let's say I created VI, now say customer, right? VI customer, and I press enter. I for insert, right click and paste it. So I have data. I'm going to remove last line because last line doesn't need, and save it, WQ. So I have customer. Now they gave me file customer, so I created that. Now I come here, it's a customer.csv. I will save as a customer.csv, no problem. Now I need to understand what it's doing. So it's reading header file customer.csv. Normally, this one, it will read in HDFS. By default, it will go to HDFS. Now state is the column, which we know very well because we group by this count, state count, and it's going to show the count. Now it's a group by state, which is this one, collect means get the data. So your cluster. And then you're looping that cluster and you're saying state is this number of cluster. So this is my program. So I'm going to do Control C, copy this thing, copy here. I copy this program. Now I'll go here. So, and I'll say VI, let's say customer dot py. I say I for insert, right click and paste it. Remember the file it is using is customer.csv. Okay, no problem. So I save it. You see, I'm not changing a single line. Now I know it's a Python program, so I'll say Spark, let's submit customer.py. That part is not given by this one. It's not given. So there is a little bit thing you need to use your imagination, right? So now I run it, it's going to say file is not found because customer.csv is not there. Right? It's going to cry. Let it cry. So at least it will give you a clue what it's looking for. It's going to give clue that, hey, I'm not able to find this file. But it also will tell you where it is looking. Right? Very soon it will say, hey, I'm not able to find this error. So it errored out. Right? It will error out. So if I go here, it says path not exist, and it is looking for customer file under HDFS. Right away, it give me clue that is looking for HDFS and this one. Okay, now I got a clue, no problem. So if I click here and I have, if I do ls -l, I have customer file, which is here. I need to put this file in Hadoop. So Hadoop fs, let's put customer, and I want to save as a customer.csv. So I'll say /customer.csv. It means I'm saving in HDFS as a CSV. So now my local file, which I had customer, I'm saving as a CSV file in HDFS. When I run this command, it's put in HDFS. Now I use up arrow, and rerun the previous command, and you get the answer. Within 5 minutes, I'm able to do, which normally used to take 40 hours, because you have to think about it. And only person can do, a person who is genius, right? Now, many of you, right now, what is it is crying? It's crying. Paths not found. User root. Oh, customers. It says customers. Oh my God. It says customers. So I'll say customers.csv. Name was incorrect. So I pushed it. Run again. Hadoop, as I mentioned before, technology is very easy because majority code you do cut and paste. It's not like Java or Python, you write hundreds of line code. Here the code will be 20 lines max. Look at that. So let's see, it got me the answer. And you can see the cluster is right away. Give me thumbs up. You saw I created in front of you clustering. You guys agree? And if you think this is hard, then what is the hard part? Trust me. If you think this is hard, people I have seen in my life, Python programmers spend like hundreds of hours, X dollar. Here you spend 5 minutes, X. And if you don't learn, who's smart, Python guy or you? I always tell people, don't miss this type of opportunity, because this type of class we don't teach often because it requires a lot of practice, because you need to know all. This is a capstone class, but I always tell people there is a book written, right? Last mile failure. Last mile failure means it's losing maximum opportunity at last mile. So please don't do the mistake. It's so simple. When you start adding these words in your resume and LinkedIn, you'll see the benefit. Trust me. Next. So that was a cluster part. Now go back to our Spark lab, which is here. Not this one. Oh, here you go. Let's go down. I create a few labs for you, which will be easier. We'll all do together as long as you are in this forum. I added a link in the chat. But let me go down. I created specifically for you because I thought it will be important for you to use this type of thing. Okay, let me give you a link here in a chat so you guys can connect. Happen in this chat. Okay. I hope you are here in my Spark lab. Now we can do any exercise of your choice, not a problem. So let's do this exercise if you want. You may like it, exam. Okay. This may be fine. Will be fine. Let's do this one. And each exercise may not take more than 10 minutes. So just enjoy, relax, just copy paste and following the steps, because majority code is boilerplate code. So here I have data file, which is kind of tab delimited, which we call exam, just for time being. We have data file called exam. Okay, so definitely we need to create a data file with vi command exam, and we can definitely create a tab delimited file, and then we have to push that file to the HDFS. I normally don't push, I get an error, and then accordingly I put it. So first create this file, we'll create that, And this program, let's understand the program. So this program say that we're going to create a builder, which is nothing but boilerplate code. There is nothing I do that copy paste, because it is that way. You are saying the Hadoop cluster is running locally. If you want to run remote, you need to provide IP address, but otherwise this is no problem. Now this is beautiful part. You can see here Spark SQL. Spark SQL. So you're running SQL command. Why Spark SQL allows me? Because here this library we are using, so it allows you to run Spark SQL. So you're saying here create table if not exist. Such a beautiful thing, right? So Spark is allowing you to SQL. You create a table with 3 columns, and then you are saying it is terminated by T and all. Just copy paste. So you create a table. Once your table is there, you are saying load data local in path. Means local means Linux. Linux has exam file. Load into my test, which is this table, the table you just created. And then you are saying run Spark SQL, run any select command and generate DF. DF means data frame, and print it. So if you can run this command, I'm hoping you can run where class. I'm hoping you can do group command, means you're done. So what is this? Technically speaking, it's a hive, technically hive. This is your external table, and here you are linking. So here you're not giving path. So you're not giving path, but if you give a location, it can read HTTPS file. But if you're not giving path, you can load the file using load command, which we learned when we did a hive. So Linux local file is copied into that, and then you can run any query of your choice. You can run preempt, you can do data save, you can do all kind of things, right? So let's do this exercise so you can see how easy it is. So I'm going to copy these 3 things, Control C. Sometimes tab is problem in copy paste. We'll try our best. So here, first we'll say VI exam, VI exam, VI exam, press enter, and I for insert, and right click and paste. Right click and paste. So if you see a lot of space, just DD. DD means delete. DD, DD, DD. So this is like has to be tab delimited. I want to see that this is tab delimited. So if I do insert and tab delimited, it has to be tab delimited. Otherwise, it won't work properly. So it's very important. It has to be tab delimited. It doesn't look like tab delimited. So, like example, if I'm here, right, it has to be tab delimited. So if it is not tab delimited, it won't work properly. That's the problem in this exercise. So sometimes let's delete it. Let's create our own. And let me delete it. DD means delete. I for insert, that's a 1, Tom, and that's a 20. 2, my, 30. T, Amy, 11. 4, Ron, 30. 5, Kevin, 44. That's it. So we have like data, and I did a proper tab delimiter, because sometimes if you don't have a tab delimiter, you may have problem. So just DD stands for delete. Delete all, and then press I for insert, and then create that file. Okay. Once you create a file, escape, colon WQ. WQ means write and quit. Write and quit. And then you can check it out, get exam, and see if that works. Give me thumbs up if you're good with this, or if you have a question, please ask. Good so far? Please understand, it has to be proper tab delimiter, otherwise it won't work because our file has a tab delimiter. So now let's go back to our Spark, which is what is it? Oh, this one. Okay. Now here we're going to copy from here. We're going to copy from here. We're going to copy up to this Spark stop. Spark stop. Up to this, we're going to highlight and copy. Control C. Control C. Copy that. Control C. Now we're going to go VI exam.py. Exam.py. Press I for insert and right click and paste. Now you always need to understand what's going on here. So you can see here, first this is a boilerplate code which will create a Spark context, and using that you're creating a table. I use three double quotation. It means I'm saying anything here follows. So it will create a table, my test, with 3 columns, ID, name, and grade. Now if you scroll down, It's looking for a file which is tab delimited. That's why it's very important that you're tab delimited. And you're going to read exam file, which is local, because you're saying local means Linux, and you're going to load into my test. So this one will create a table, this one will load. After that, if I run the query, if it works, I should see my data. And that gives me df. If I want to print df, I say print df, and then df show, which is show the result. Printing schema, schema will show the column and all, and then stop. Very simple, there's nothing special here, right? Escape, colon WQ, escape, colon WQ. Now just run it. So Spark dash submit, Spark dash submit, exam.py, exam.py, Spark submit, exam.py. So whatever the program which we copy paste, we're going to run here. This program will create table, and then the data which you have, it will load it, and then it will run query. Once you run this query, you can run any query. So press enter. Unexpected intent. This is one of the problem in Python. So it's going to create, drive us crazy. This is where I don't like cut and paste, and Python is always a crazy guy. The reason it's crazy thing because you see this, it doesn't like if you do this properly. So I believe this space is causing trouble. Let's see if that's all. Otherwise, I have to remove the space and all. Python is alignment specific, so if your alignment is not proper, it won't not. There was a space between this command, so I removed the space basically. So when you run this command, I had a space. These two lines should not have space. This line should not have space. So I just remove dd. dd means remove the empty space. That's all I did. Now I ran it, it worked successfully, and you can see how beautiful it is. I get me table, I get schema. So what is this exercise about? This exercise, if your table, sorry, data, if you want to create a table on fly, Spark can create a table. Spark can help you to load this thing. And then you run a query. You run a query. So if I want to, if this table is created properly, normally it creates in Hive. So if it is created properly, then if I say Hive minus E, if I say select, start from my test. If it is available in Hive, I should be able to run this query. It means Spark has done its part, and we'll see Hive. If it is connected properly, it should work. So Spark can complement Hive, which is kind of nice. So if metadata and all correct, look at that. And if Spark can complement Hive, then Hive can complement Hue. Oh my gosh, it's a beautiful thing, right? Spark did a heavy lifting. After Spark, you can run any ad hoc query, either through Hive or through Hue. It means now your business user has the ability to run any query. Think about it, you can do all the massage, and at the end of the day, you create a table, put it in a Hive within 2 minutes. Majority code is cut and paste and redundant code. So you don't have to learn as such because you are not typing them, right? Code is, you can see here, if I go to VI, code is very simple. The code I gave you, remember I removed the space. This is a Spark context. This one is creating table. If I change this table name to different table name, then you use that table. Then here, this command, Spark SQL, take this file, this is data file, this is your table. You're loading to here, whatever table name you load, and then this is just testing purpose. Once you create this thing, then this one exists now, how you can talk, you can talk. That's it. It's a beautiful way you can make your data accessible via SQL command. Question, concern, doubt. We may not take a break. I may be done in maybe next 20 minutes if you guys are okay. We can continue. Maybe we should be done around 8 o'clock. If you guys are okay. Because cluster will cost me money unnecessary, and we should be able to complete. I think we are going smoothly. Okay. Now let me show you join part. I think you may like that. So I created a special lab for you. Now a lot of labs are there. Play around. It's fun. I want to join. Yeah, this one. This is my favorite. This is I created special because majority in my work, I have this type of problem. So I get data, like example, customer data, I get order data, I get transaction data, like that. So I need to do all the joins and then run query on top of them. Takes column from here, take column from here, take column from here, and then ad hoc reporting will happen. So most people, this data is very confusing and you need to do joins and all. So how it works? So I created a tiny exercise for you. I hope you will enjoy it. So here, first I created first file called file1 CSV, where your customer ID, name, and date. And the second file I created is our customer has age and date. Okay, so I use two columns for uniqueness, just to give idea. I can use one column also, but here too. So I want to take column from here. I want to take column from here. So basically, I want to show you how I do join. So two files I'm going to create through VI. I'm going to create through VI. Once I create a VI, I can say how to put this file into HDFS. Put this file in HDFS. So two files are pushed to HDFS. Then I'm saying run this thing command. Again, this is boilerplate code. You get a Spark, and a Spark is going to read this file and say if header is true, and read this file and read this file. So it will create two RDD. So there are two RDD created. Once you have RDD, you are going to show one by one. So you can see that you are able to read this file and you are able to read this file. Now you are saying merge this thing. Merge into two files using primary key ID and secondary column date, which is beautiful. You have to pay attention, you may like it. So you are saying file one, which is this one, join with this two column, file two. So you're joining to this file, which is this one. So first file, you're joining with this. So you're saying file one dot join, where file one ID matching to this one and file date matching to do. So basically in two files, we are using two columns to do matching. If you have one column, you don't need this thing. But I have two columns. I'm checking ID has to match, date has to match, and then get it. Then we are saying if it is matching, I'm interested in first file, I want to interest ID. First file, I'm interested in name. First file, I'm interested in date, and second file, I'm interested in age. So these are the column I'm interested in. So that will be in a merge data. And then when it says show it, you will see the data. And then I'm writing that file into file. So the final result I'm writing into file. And that file I will show you. So basically all processing will happen and the final merge result will be written to this file. Please understand, whenever you work with Hadoop, it doesn't create file, it will create a directory for you, right? So if you want to see that, you can see this thing. So Hadoop FS, this is your directory, inside directory start, and you will see that it will be merged result. You will see all the results in a merge format. Okay, so let's do together step by step. I hope you are here, right? We're going to copy this portion, Control C, right? Let's go here, step by step. Okay, VI file1.csv, file1.csv, press I for insert, and right click and paste. Boom. If any empty lines you have, just go there, escape DD, escape DD, escape DD. So you have nice file. This is the ID, this is the name, this is the date. Any empty line, I do escape DD. DD means delete the line. Make sure you delete the empty line. Now escape colon WQ. So your file, double check the file, cat file1.csv. So at least my file is good to go, file 1. And same process we need to do for file 2. So let's do it. VI file2.csv. Press I for insert. Go to Spark and copy this line. And and paste it. Make sure it's insert first. Paste it. Again, escape. DD. 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 Escape column WQ. And double click and cat file2.csv. Give me thumbs up if you're having file ready, so we can move to the next. I have file 1 and I have file 2. Okay. Trust me, many of my colleagues, when you work together, they spend a lot of time to do this thing. But I have like our forum. Because of the forum, I can cut and paste the code. I don't have to do research because I know the concept. My data file might have more columns, but I hope you understand. My data file have more columns, but concept remains same, right? So it's not a big deal for me because I just need to change only column and good to go. So I have two files. Now, go to forum. We're going to run copy command to C and right click, paste it. So that will copy file 1 to HDFS. And we can do here, Control C and paste it, and it will copy file 2 to HDFS. Any questions of both files, which we just created, are pushed into HDFS. Good. Now it's time for us to write a program. Sorry.
Just quick question, and if not, I know how to go back and fix it. My first file, I just named file.csv. Is there a way to rename, or do I just recreate a file one?
MV, whatever name, file name, and new name.
I'll just move. Okay. All right, I'll do that.
I hope you are taking my Linux class on Wednesday, or command I teach in there. Many of you are taking, make sure you take this. Linux is very powerful. So you can rename the file MV, original file name, and new name, space, MV space, old name, space, new name. And even your file name is incorrect, you can give a file name and you can do dot, whatever correct name you want, you can do that as well. So old name, dot, / new name, and it will be showed in the new name in the HDFS. Now it's time for VI. We need to use new file, which is this one. So this file name we will create a merge.py. So we're going to create merge.py, but we'll copy from here. Make sure you understand is copy portion is here. So Control C. I have done like hash sign. It started from here. So you hash sign and stop here. Control C. So hash sign, hash sign, hash sign, hash sign. Now you copy here VI, and in VI we say merge.py. Merge.py, I for insert, and P for paste. Again, normally I check this type of thing, so it should work without any problem because file names I didn't modify it exactly here. Everything looks good. Columns are properly done. I always test my program before I run it, so everything looks good. At the end of the day, my output will be returned into this file. So escape, colon WQ. Again, we don't change it. If you want to double check, cat merge.py, always good idea to check that. Now, you know what to do. Spark dash submit, that's your prompt, and then you can say merge. So when you run it, it will read two files, it will merge it, and it will generate a new file, which is most of the time my use case. I get lots of file, I process it, write it. That's all my use cases. So if you do one exercise, all my project, you can be successful because instead of 2 files, I may have 5, 10, 15 files. But I do the exact same thing. And it's repeated. So now it becomes a second nature for me. It's done. And once it's done, I just want to make sure I'm able to run the data and see merge has an extra column coming from both files. So if I paste this thing, the last output is merge output.csv, and you can see result is there. I have ID, I have name, I have date, and I have age. Age came from the second. How simple it is. So Spark is very powerful with the Python. Any questions, concerns, doubt?
Tushar, in real life, we need to have a file and then we need to load in Hadoop, right? Not like we create like
no, in real life.
Data, yeah.
Yeah, in real life.
And
I'll show you 1 second. In real life,
could you give us an example? Like
this is the large file. Okay, this is the web page, and I paste it. So this is the large file. You see how data is? Say yes.
Yeah. Oh.
You
Yeah.
need to say, yes.
This looks like real life.
This is 1,000. So goal of the exercise, when you do the exercise, you always do sample data. So you can be faster. These are hundreds of thousand data, right? It will take time. So if you make mistake, every time it take time. So you always start with a simple, like maybe take 2 lines and do the exercise. Once it works, then run on a large data. So this exercise, let's do it here. This is available in our machine learning, which is, I think, last exercise for today. So if you search machine learning exercise, this is like a wget. So how this works? So normally in a real life, this is the Hadoop. You only get data 2 ways. One, you use wget. Wget, it run on Hadoop. So you pull the data. That's one way. Second, you get data from FTP. So you get data from FTP. So you write FTP command and get the data from FTP. These are 2 ways normally you get data. And third, which we talk about, if your database, you get data through scope. This is the only way I think you can get data. Normally people don't do other way. Mostly people use FTP or wget or database. Mostly people use scope. FTP, you can use FileZilla, or you can transfer file, or you can write FTP command and you can connect, and the command is get. Get means you get the data. So data came. Doesn't matter data, how it comes, right? So here, this exercise, your large volume of data. So I'm going to run this command, right? So I get data. And once the data comes, it's going to bring this file. It's going to bring this file. Now that file I get, I'm going to put it in HDFS and I'm going to run this command. Make sense? So what I'm trying to do here, let's run this command. So you'll understand. In this command, I'm creating a Spark context, and using Spark context, I'm using SQL context. So here, SQL context is coming for high, basically. So Spark context using SQL context. And then I'm saying read this file, but this is a lib SVM, that's a special formatted file. So you read it, you get a training data. Training data is always sample. Please understand, training data is always sample. So anytime you want to run module, so this is library, which is SVM module, you're sending the data. So it will create linear regression model. So here you are using logistic regression and you are saying max iteration 10. So just do 10 iteration and regression parameter is 0.3 and elastic net parameter is 0.8. So you're looking for the information about how I'm going to run this data. So you basically want to create the M and C, which I'm going to cover in your data analysis class, but you basically are doing slope here. So slope is this is the slope. So basically anytime you do regression with linear regression, you have formula mx plus c. So this example is going to get you the linear regression. Then it will help you feed that and get me the model. So you will get mxc. So at the end of the day, you get m and you get c. Once you have m and c, any next value, you can put that and you can predict. So this whole linear regression and everything comes from this simple library, and that is called machine learning library classification. So when somebody said machine learning, it's in my understanding, if you ask me, it's a buzzword. Technically, they're talking Python. And then on top of Python, they're talking algorithm. Machine only learns through algorithm. And there are 9 or 8 algorithms you need to know. One is linear regression, one is the classification, one is decision tree, one is clustering, one is recommendations, one is association, right? These are like 8 or 9 known algorithms. That's all you have. So if I want to do this exercise, I need data, but data comes from this command. So data comes from this command. These are Linux command and Hadoop command. So you get the data. This one will generate that. Now, this is something you don't write it. You borrow it. Scientists will give you this. Logistic regression is a regression which many of you don't know, but this will scientist will give you. Data science person will be there. He will say 10. If you have a higher number, you have more accuracy. Ultimately, you create a model, linear regression. And then you're saying fit. Fit is nothing but your data. Your data is like this. And you're trying to do line, which I talk about I will talk about on Thursday class. That line has to fit properly. If it's perfect fit at 45 degree, then your perfect relationship, which is correlation, is 1. But if it fits like a particular interval, then correlation might go. It has to be 0.95 or above. So this one will give you the coefficient here, right? It will give you the information.
What is, excuse me, Tushar, what is that max ITER? Is that slope of this, linear regression?
Iteration. How
Slope?
many times? No.
Iteration?
Iteration.
I see.
In order to find a proper model, these algorithm will run 10 times to get the proper value from the model, from the data. So the data which you're using, the more you run, the accurate this model will be. This model, after getting this training data, which is this data, after getting this training data, then you get the M and you get C. So you are getting this one. This is the C. C means your intercept, and slope is your M.
Yeah. As much data as we have, as accurate the slope is of that linear. Yeah.
Exactly. Let's do it. If you want to do it, you can do it. It's not going to take more than 2 minutes. So copy this command, wget, right? See, this is fascinating to me because it's so easy. And that's why I'm always worried about like why people are afraid of doing exercise. You see wget, you got the data. This command, download the data. If you want to see cat, just say sample, and this is your data. So you got the data. It's a large file. You see, it's a very large file. You download it. Thousands of records. Okay, you got it. So you download by running just simple one command, get. Now you run this command to put this file in HDFS, right? Which you know very well, how to push the file in HDFS. You take this file name and you can say dot, it means it will push this file to HDFS. That is done. Then
one more question, Tushar, before you go. Is Hadoop capable of loading any type of data frame, like CSV file you show us, and the text data, and other file extension?
If you don't
Is
have,
it capable to load any type of data?
yes, that's why you should use loader. By default, if it is comma file, like 5-delimiter file, semicolon file, those it's easy to understand, and that's why you specify how to read that file. But if you are, let's say, file come in JSON form, file come in XML form, then there are some loaders available to load that thing, and Hadoop can easily do that. But yes, it can load. Hadoop is not for structure. It can use structure or non-structure. It can read XML, it can read JSON, you can read any data. That's the beautiful part about it, right?
It's cool.
Peak was designed for that. In case if you remember, Peak has a concept called peak storage. Peak storage allows you to read data from Cassandra, Mongo, you can read any. Pig means animal which can eat anything. That's why pig can read anything. Right? That's why they give a name pig. I'm not kidding. They give pig name because pig can eat anything. Pig can eat paper, pig can eat vegetables, fruits, anything. That's why they give name pig, that this program can read any data. That's why they give name pig. Okay? Now I downloaded data. I'm going to copy this thing, and Control C. I'm going to name port.py or whatever name I want. So here vi, let's say port.py, I for insert, right click and paste. Please understand, you don't need to be a scientist in order to do this exercise. This is the only thing they will give you. This one, they will give you. This is your data, which you read from the file with this model. This is the algorithm name, and then you are creating the data. You give this model. So this is your training data. Now this will get you M and C. So if you're M and C, then now if you want to do Y equal to MX plus C, the only thing is missing C, X. So if you give me X, I already have M, I already have C, then I can predict next. So this is the prediction perspective. So if I do save this program, and if I run same concept, Spark, submit, port.py, it will create that and it will give you M and C. Now it's crying here. The reason it's crying because it's missing library NumPy, right? It is missing library NumPy. So if you want to install, you can just say pip install NumPy. So whenever, if you want to install library, just say pip install NumPy. It's this NumPy, pandas, those are Python library, which we'll learn on Saturday class. So that's why Saturday class is very important. I know some of you are smart. You already know Python, but some of you don't know. Please do come on Saturday. It is part of your ecosystem. We are not going to charge you $1 extra. But if you don't know Python, you don't know Spark. So there is no way you can move forward. So it's very important that you have Python. Oh, sorry, I already have this thing. Up arrow, and let's see. So if everything goes well, it will read the data file and it will generate M and C for you. Whatever we have studied here, trust me, even highest level course people don't teach. The only thing I would encourage you to practice. But you can see here, intercept is calculated here. This is the C and your M, so this should be here. So where is your M? Where is your M? Intercept was here. Where is the M? Somewhere. Are you guys able to see or I missed that? So much thing it prints, it's hard to find where is my.
I see intercept.
I didn't see anything.
No,
Oh,
got one.
Intercept, I can see.
Other one
Now
should
my
be
eyes are starting to cross.
my eyes are also. But it is somewhere. I should have stored in a file in that case, but it's definitely there somewhere. This is executing. So
Intercept is like in that first block. If you kind of just look up, you'll see the word intercept, and it's got -0. That one was kind of easy to spot. I can't find the.
That was the. I think this is the one. I'm assuming it is here only. It's you see here.
Oh, coefficient.
Yeah.
I can't see anymore.
Yeah. Makes sense. So this will create a YMX, and you may say that many websites can predict, right? How they predict, right? They do this thing, right? The regression part is very interesting. And of course, you can use this for many algorithms. You can do. I want to cover one more algorithm. I have user, right? I have user ID, I have product ID and rating. So I have user ID, product ID, and rating I have. So knowing that this user by product ID and his rating, that I like this product 5, I like this 3. So this is the rating. Now, knowing this model, I want to ask who is going to buy next item. So example, if number 1 is going to buy something, what is the probability or ranking they're going to buy? So we can give a recommendation that he may buy 102, likelihood this, he's going to buy 103, likelihood this, something like that. So first, we're going to create this file, rating.csv, last exercise. Then we'll push to the Hadoop. Then we'll run command. This one is called product recommendation. So we are using product recommendations concept. So we'll read this file. Of course, we're going to read it from HDFS. We say we header and we don't have schema. So now, once we come here, we are using ALS algorithm, which is a collaborating filter. Collaborating filter means if I don't find the correct answer, ignore it. Don't go crazy. So here we are saying these are columns, user ID, this and these are the column. And our strategy is if I don't handle properly, just drop it. So that's what the collaborating filtering means. Don't go crazy. This is more for trial purpose. In a real production, we don't use this because in production, we need to do a little bit much better. This is a quick and easy algorithm. But ALS is open algorithm, it's a free algorithm. You can read about it. Again, this one will come from scientists. You don't have to do this one because they are the one who is knowing this algorithm. They will give you one line for you. That's all. They will give you one line. Now, using that line, you're fitting the data. This data, you read it from this one. So this is your data, which you read. So you're passing and you're creating a model. So whenever somebody say model, it's nothing but this model data you pass, and using these algorithms, you generated this reference point. So you say, what is reference point? I'm not understanding. Very simple. Your data. From data, you create a model, like example, this model, just an example. I'm creating model. Now the new data point comes. You use this model and you refer and predict the next point. Now this, I'm just giving you a simple example. It gets complicated. Like example, if I give data and this model say A for apple, B for banana, and C for cat. So next data comes, it will refer this thing and say, oh, your apple, oh, your banana, oh, you. That's called recommendation means. So the model has a reference point. Using reference point, it make a decision. So first you give a data, that's called training data. Using training data, you create a model. Using model, any input comes, you use the model to generate the output or prediction or reference. So anytime somebody give you recommendation, it comes from model. When you say ChatGPT, what is ChatGPT? ChatGPT take entire world data, and then they spend 6 months, day and night, listen carefully, 6 months, day and night, with 60-70,000 machine. How many? 60-70,000 machine, day and night, 6 months, entire world information, and then they create a model, which we call ChatGPT 4, model 4. Before that, Turbo 3.6, that's a model. Model is nothing but a reference point. Now you ask ChatGPT, generate Python program. It take it and generate a program for you. So if model is good, the result is good. That's all. And these models are created through algorithm. And these are proven algorithm. It's not created today. They are created for many years, and there are many scientists have done. So we are using the, I would say, benefit of the algorithm, which is already available. That's why we call machine learning library. Library means somebody did it, we are using it. Okay, we are not writing the program, and there is no point to write because it's freely available. Now, what we are trying to do here, we are recommending two things: user to product and product to user. So something like that. So you will see that how it works. So right now it is also looking for NumPy, no problem. Let's start one at a time. So first we're going to copy these things with heading, and we'll say rating.csv. So go here. Promise this is the last exercise. Rating.csv. I right click and paste it. Oops, a lot of space. I need to do dd 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 and say wq right and check out that file is correct, which is correct. Rating.csv. So rating.csv is here, no problem. Now we need to push this file. So I'll put this file into Hadoop. Please understand, we're pushing that to the Hadoop, which we know very well. We have done quite a lot. The file which you created, you push. No problem. Now we have to write the program, which is called recommendation. I'm not going to write such complex names, so we'll say 5.67, whatever it is. That's all I have. Control C. What it does, let's see this. So I'll do fifth dot py, just trying to avoid the naming convention problem, make it easy name. You can give any name. This entire program is dependent on the algorithm, and that algorithm is ALS. So if you want to read about it, you can spend, you're going to go crazy. It does recommendations, all users. It also does product recommendations. This is what Netflix use. When you watch one movie, Netflix can tell you what movie you like. This is also used by Amazon. When you buy one product, it will say you may also like this product. This is very popular algorithm, product recommendation. It's a very popular, it's a freely available, and most companies use it. So now escape, colon WQ, I push the file. Now time for us to run it. So Spark, Spark, submit, fifth.py. .py now is going to read the data, run the ALS algorithm, and it will do product recommendation. Because of space, it sometimes truncate the data. So I have taken a picture, which I'll show you. You see, it started generating. So first one was, I think, product recommendation. Second is the user recommendation. It's done. So you can see here it generated the product recommendation. So it truncated that because of the space issue. But if you see here on the screen, I have explained here what it does. What is this algorithm is, I explain here, but here is it does. So it's a user 101, 4.5 recommendation, 102, 4.2. So when Netflix show the movie, the first picture Netflix show because of this high recommendation, the second picture and third picture. How the order decides that which movie you may like is based on this rating. Now, same thing for second guy, right? So now this rating change every day because let's say Netflix recommend this, but you watch this movie, then Netflix have to rerun the algorithm again. Netflix does pretty good job, and that's why Netflix is very popular to recommend you watch movie you like. So this is called user which product they like. And if you do reverse product, so based on product here, so product ID is here, and product what user will purchase. So user 1, 5.0, user 2, 4.0. So this product, who is going to buy? This user is going to buy. So that's why Google does do context marketing. Many company does marketing. This is called target marketing. This user may buy this product and your highest score. This one may be lower. This is high. So this product, if you show to this user, most likely he's going to buy. That's why not every advertise, everyone see that. Some people will see certain advertise because Google has done that thing, and that's why they show the left navigation, some of the advertisement, or YouTube, they show the advertisement. Google knows you based on your search pattern. Based on that, Google run the algorithm to show which advertising to show. Same concept apply for Amazon. They recommend certain products to you, or they send you email. Hey, these are the products, because they want to bring product in front of you so you can buy, because they know that you want to buy, because your 5.0 means almost 100% confidence. You see, total line of code is only 10 to 15 lines, and this is your machine learning, and this library is machine learning library, product recommendation. So if tomorrow, if you go in interview, somebody said, do you know machine learning? Don't say no. You know, clustering we show, classification we show, and product recommendation we show. So there are only 6 or 7 algorithms out there. If you spend some time, you can do all 6, 7. That's all I have from